All right, I'm going to really over-exaggerate this so we can kind of get some perspective here. It's only 7-degree slope, and I drew it way more than that. Truck parked on the hill, force gravity goes straight down to the center of the earth. We've been doing that. 4,000 kilograms, which is really 40,000 newtons. And I have a normal force that goes up like that, force normal. Couple things here. There is some force of friction because it's parked on a hill. So we have a piece of friction, force of friction, static, pointed up the hill. This is in static equilibrium, so sum of the forces equals 0. Let's bust down what my forces are. Remember we said we can draw this piece there, call it force normal, and put the 7 degrees in there. And then I have a piece pushing it down the hill. This is the net force. It has to be equal and opposite to that piece because they have to balance out. I already force normaled my Y piece, and this right here is really my X piece if I tilt my axis. So this is the X and this is the Y right there of my force gravity. And again, it depends on how you look at it when you tilt your axis. So what I'm going to do is I'm going to solve for that force net up top. I have hypotenuse. Remember, this is a right angle. This is the hypotenuse, and the force net is opposite. So O and H is sine. The sine of 7 degrees equals opposite, which is force net, divided by hypotenuse, which is 40,000 newtons. How do you get force net all by itself? Multiply both sides by 40,000. 40,000 newtons multiplied by the sine of 7. Alright, I had to grab my calculator, and now I'm going 40,000 multiplied by the sine of 7. And I'm going to get force net equals 4874 newtons. And that has to be equal but opposite. So we're going to say to the force friction static. So we're going to say force friction static is negative 4874 because it opposes motion. And we'll put a newtons in there. Woo woo. Woo woo.